Hey guys. Okay, let's keep going. So now it says, suppose PQ has one endpoint 0, 0. Okay. If 2, 5 is the midpoint of PQ, what are the coordinates of Q? So let's think about this for a minute. One endpoint is 0, 0, right there on the origin. And if we had a point 2, 5, that they're saying is actually the midpoint of PQ. So I'm going to call that M for midpoint. So what they're saying is this is just the first half. There's the rest of it is sticking out. So they actually are giving you a slightly different question than we practiced in class. They want to know, what is this point? If the midpoint is here and we started here, whoop, whoop, what's this point? So let's go to some graph paper and see if we can figure this out. I actually like figuring these out with graph paper a little bit better than algebra because I'm a geometry teacher, right? So my coordinate is one end is 0, 0, and the midpoint is 2, 5. So let's take a look. All right. One point is 0, 0. And the midpoint is 2, 5. Okay, so the midpoint. So it says the end of the segment right here, and I think they want us to call it PQ. So I'm trying to figure out, where is Q? So I'm thinking Q is somewhere over here. I might not be exact, but I'm close. So let's figure out if we can use this idea of slope, right? Some students had brought up this concept of y equals mx plus b, the slope of a line. And it's kind of the same idea that if a line is straight, it has the same slope. So let's figure out this slope. It looks like it goes rise, 1, 2, 3, 4, 5, and then run 2. So that's the midpoint. So if I want to continue, I just keep going, rise 5 more, run 2. So if you think about this mathematically, coordinate M is 2, 5. And so we just want to keep going, another 2 and another 5. Kind of interesting, right? So point Q should be at the coordinate 4, 10. Let's check that out. So 1, 2, 3, 4. 2, 4, 6, 8, 10. That's perfectly right. So that's what they're looking for in question number 12. What is this coordinate? If I'm at 2, 5, then I want to go 2 more and 5 more, so I get the coordinate 4, 10. Now it says, how would you find Q, the end point, if 2, 5 wasn't the midpoint, but it was a quarter of the way there? So now, this is interesting, right, guys? I want to just keep on going. So if this was a quarter of the way there, then I want to go one more, one more, one more. The point's way over here, right? Because this point is only a quarter of the way there. So let's go back to our graph paper and see if we can just keep on going. So this is, I went over 2, up 5. I want to go over 2, up 5, over 2, up 5, over 2, up 5. Now this point isn't the midpoint anymore. It's a fourth of the way there. Cool. So this coordinate would be 2 in the x, plus 2 in the x, plus 2 in the x, plus 2 in the x, and plus 5, plus 5, plus 5, plus 5 in the y. Okay, so let's go back to our work, and we can show our work here. Cool. Okay, so I went 2 plus 2 plus 2 plus 2, and then 5 plus 5 plus 5 plus 5. Some of you even had a shortcut. Repeated addition is just multiplication. So you would be like, yeah, that's going to be 8, and that's going to be 20, and that's going to be my answer. Okay, one more on this sheet. It says higher, oh, not one more. Okay, oh, this one we're skipping. Okay, yep. This one we're skipping. So now it says 15. The endpoints of RS are negative 4, 3, 8, negative 5. Negative 4, 3, 8, negative 5. Negative 1 1 is what fraction of the way there, and 5, -3 is what fraction of the way there. These I think we can just do by graphing. So let me take a picture of this because I'm going to flip back and forth. So that's going to be easier if I take a picture here. Okay. So going back to my graph paper, 4, -4, 3. So -4, +3. It's a little messy, but not too bad. -4, 3. And then 8, -5. So 8, -5. 1, 2, 3, 4, 5. Okay, S. Beautiful. Now let's think about this slope here. I could use the slope formula. I could just kind of count my boxes. It says the coordinate 1, -1 is what portion of the way there? So this is 1, -1, 1. So let's figure out how far did it take to get there? So it looks like I went down 1 over 3. And if I continue that, down 1 over 3, down 1 over 3, down 1 over 3, I don't know about you guys, but that looks like 1/4 of the way there. So we found our answer. If I cut this into 4 equal pieces, so it looks like the slope is fall 2, run 3. If I cut this in 4 equal pieces, it looks like this is 1/4 of the way there. The coordinate, -1, 1, is 1/4 of the way there. Now the other coordinate, 15b, what about the coordinate 5, -3? So let's see where that is. 5, -3. Ooh, that landed right on my grid line. So let's look again. That looks like I'm 1, 2, 3/4 of the way there. So this coordinate looks like it's 3/4 of the way there. 3/4 of the way there. So we've got our final answer. Let's flip back to our answer page. This one we said is 1/4 of the way there. And this is 3/4 of the way there. Cool. Okay, it looks like we have a little more time to squish on this video. Yeah, so let's take a look at 22 and 23. Most kids got this, some kids were able to do this in class. They practiced. How far apart is Arthur and Jamie? So we have Arthur and Jamie. We have their 2 coordinates, right? So Arthur is at 20, 35, and Jamie is at 45, 20. So notice we subtract the 2 x coordinates, 45 minus 20. Subtract the 2 y coordinates, 35 minus 20. We get 25 squared plus 15 squared. And we end up getting our final answer, 29.2. So that's our answer. Now, some students were like, Jamie's closer just by looking. That's their explanation. I would take that. And some students wanted to actually calculate it. And I was like, yep, that's okay too. So the distance from Cameron to Arthur, if you calculated it, was pretty far, right? I got 45.3. And the distance between Cameron and Jamie, I got 28.3. So it's very obvious that Jamie is closer because 28 is much closer than 45. Cool. All right. We just had these last 2 questions. Check out the last video.